Okay, so for AMI day 3, we started off the same way we did day 1. We are writing the equation of a tangent line. So we need y minus y1 equals m times x minus x1. Now this time, they gave us both our x1 and our y1. So that just means we need to find dy dx at that point. So we plug in those two values, and that gives us a slope of 8. So y minus y1 is 2 equals m is 8 times x minus x1 is 1. So that's our tangent line, and that's technically all we need for part A. But part B says we're going to use that to approximate f of 1.1. So it would be helpful to go ahead and get y by itself. So we'll distribute that 8. So y minus 2 equals 8x minus 8. Add the 2 to both sides. So y equals 8x, not plus, minus 6. So now we want to approximate f of 1.1. So that's going to be approximately 8 times 1.1 minus 6. So f of 1.1 is going to be approximately 8.8 minus 6, which is going to be 2.8. So that's only the first half of what we need to do for part B. We want to decide, is it going to be greater than or less than f of 1.1? So the way we're going to be able to do that is by thinking about like the concavity. So if we have something that's concave down, a tangent line is going to be below the curve. If we have something that's concave up, a tangent line will be above the curve. And so that is why they have given you that second derivative. So we want to find the second derivative at the point 1, 2. So 2 cubed is 8. Then we have 1 plus 3 times 1 squared is 3 times 2 squared gives us 12. We're not really concerned with the number though. What we're concerned with seeing here is everything is positive. So since that is positive, that means that f is concave up. So the tangent line is under the curve. Then part C, we want to find the initial, or not the initial solution, we want to find the particular solution with the given initial condition. So when we're solving a differential equation, we look at our dy dx. We need to separate our variables, which means we want all the y's on left, and we want the x on the right. So that means we're going to divide by y cubed, and then we're going to multiply by dx. Now this y cubed might be easier to think of it as y to the negative 3. So when we integrate this, we add 1 to the power, divide by the new power, and then that's x squared over 2 plus c. So I'm going to do a little bit of rearranging first. So I'm going to multiply everything by negative 2. So that's going to give me 1 over y squared equals negative x squared. And then negative 2 times c, you could write it as negative 2c, but it's really just another constant. I'm going to go ahead and solve for the c right here. So we're going to plug in 2 for y, which is going to give us 1/4. We're going to plug in 1 for x. So now when we solve for c, that is going to give us 5/4. So we'll plug that in. We'll have 1 over y squared equals negative x squared plus 5 over 4. So now this you could rewrite as saying negative 4x to the 4th over 4. And then that would mean you could combine those into a single fraction. So we'll have negative 4x to the 4th, or sorry, the second. I don't know why I changed that to a 4, plus 5 over 4. Then we can flip both of those fractions. So we'll get y squared equals 4 over negative 4x squared plus 5. And then we will take the square root of both sides, which technically gives us the positive and the negative solution. But our initial condition, f of 1 is equal to 2, is positive, so we only need the positive solution. So that should be our answer to our part D. So you guys let me know if you have any questions about that, and I'll make another video for your day 4.